Hello and welcome to our video on surface area of cylinders and also composite solids. Now cylinders are a special type of prism that have two circular ends and they're long and tall. If we go back to what our thinking was to do with prisms, we were looking at two of the sides were the same and opposite faces had similar areas. So we can see here that the top and the bottom would have the same area because they're both circles, but this curved side around the outside of the cylinder is a bit harder to visualize what it would look like. If we take a look at the net of a cylinder, it looks like this. This one I've got here. You've got your two circular ends, and something interesting happens when you pull it apart, that this curved outside bit is actually a rectangle. So we can use that to help us find the total surface area. So let's label some of these bits. Inside a circle you would have the radius labelled. Normally I'll just put that as an R. And what we can find is this length along here needs to go all the way around the circle, and we know the circumference of a circle, the formula is 2 pi r. So this length is going to be the same as all the way around the outside. So it's going to be 2 pi r, this length. This length is just the height of the cylinder, which is this one here. I'll put the radius on here as well, or the radius might be in the top. They'll both be the same radius. This is the height, this is the length of the rectangle. If we label our shapes again, or our faces, just to help with what I'm going to work out here, we can say the total surface area will equal the area of A plus B plus C. A and C are the same. So we can say 2 times A, which is the same as A and C. Now B plus B, I'll write that in. Going back to A, the area of a circle is pi r squared. And B is a rectangle, the length is 2 pi r. And times that by the height. You could put a little times in there if you want, but remember we don't need to put a times, we can just write it all next to each other. It means times. And we end up with a formula here, 2 pi r squared plus 2 pi r h. For our first example, it says find the total surface area of this cylinder here. You might like to pause and have a go at doing this yourself, otherwise you can continue watching. Okay, again I'm going to offer you two different methods. The first one here is to use a net. So if we draw our net out, whoops, that would be a more perfect circle usually. Our radius is 4 centimeters. Our height is 10 centimeters. And this length here is going to be 2 pi r. Label my sides. TSA will equal A plus B plus C equals 2 times pi r squared, which is the area of one of these circles, so 2 of those, plus, I'll make that C look a bit more like a C, plus 2 pi r times 10. Okay, now we need to substitute our r in, which is 4 centimetres. 2 pi times 4 squared plus 2 pi times 4 times 10. And putting that into the calculator, you should end up with 351.86. Now this is in centimetres, and we're looking at area, so it's squared. Method 2. Exact same question, different method. We're just going to use the formula that we worked out back here, this one here. You could just plug this straight in. So, the formula that we need to write here, always start with what you're going to be doing. Total surface area, terrible looking, eh? Equals 2 pi r squared plus 2 pi rh. Substitute the values in. 2 pi times 4 squared plus 2 pi times 4 times 10. And you'll end up with 351.86. This is in centimetres, and it's area we're working out, so it's squared units. Composite shapes. Same thing when you're doing three-dimensional composite shapes as when you're doing two-dimensional composite shapes. You need to break your shape into 2 or more smaller prisms and add the surface areas of each. So if we're looking at this example, we can break this into a cylinder plus a rectangular based prism. And you can work out the surface area of the bottom bit and then the surface area of the top bit. Now what you do need to watch out for, and I've put this in red so you don't forget, you don't need to include the surface area of the faces that are common to both shapes. That means the faces that are touching each other. I've got it coloured in here because imagine if you're painting the outside of the shape, you wouldn't be painting that inside bit. If you were covering it in wrapping paper, same thing, you wouldn't need to cover the inside bit. So when I go through the examples, I'll show you how to make sure that you don't include that little bit there. Okay, second example, find the total surface area of this composite solid. I'm going to label my 2 solids. Total surface area will equal the total surface area of A plus the total surface area of B. If you didn't want to label them A and B, you could write it as total surface area of cube plus TSA cylinder. Either one is fine. Total surface area of the cube is going to be, cubes are pretty cool because every side is the same. There's going to be 6 sides like a dice. So it's going to be 6 times 10 times 10. Easy. So that's A. B. Oh, I've swapped them around. A is the cube, B is the cylinder. Total surface area of the cylinder. Now, if we look at our formula up here, we had 2 pi r squared, which was the 2 sides, the top and the bottom, or the 2 circles, and 2 pi rh, which was the curved bit. So we can include the 2 pi rh, which is the curved bit around the outside. But this bottom bit we've already included when we've done the base here. So all you need to do because we've already included that bit that's taken out, instead of adding this on the top, we'll use that bit that we've already got. So we don't need to add anything else on there. It's already included. Substituting our values in. 6 times 100 plus 2 pi times the radius here, which is going to be 5, and the height, which is 8. When we put all of this into the calculator, we end up with 150,796. This is in meters, and its area, so it's square units. Thank you for watching this video.